I'll be talking about beats on this one, and I will use the same example that we have been talking about with cars. So then there's just a circle, a cycle that cars are racing, and there's the black car and the red car. The black car is moving slower, and the red one is moving faster, and this is a 1 mile. So if two cars is on the track, and if they are traveling at the same, they will never pass each other, and if they're traveling at the same frequency, they'll never pass each other, and they will continue going on without hearing any sound like wugga 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 wugga, because they have the same frequency. But when they're traveling with different frequency, they are having a different speed, and one car will be going faster and one car will be going slower, and that causing them to overlap each other. But each time if overlap, they will not overlap at the same spot. It will pass it and go around it, and the next time when it pass, so for example it passed right here, and then the next time it might pass right here, so it will happen at different locations. Also, when you notice or hear the overlap is happening more frequently, that means that one car is moving pretty fast. And when it's happening very slowly, rarely, then you know that the car is moving pretty slow. So when moving around, the faster car will move exactly 1 lap faster than the slower one, so it will overlap 1 lap. So like how you wrote here, if speed of frequency does not equal the speed of the sound, then lapping will happen. And let's pretend that every 4 minutes the overlap's gonna happen. So then we will use this equation: speed of frequency equal speed of the sound plus 1 additional speed, and that would be for the faster car. Okay, sorry about that, my mistake. This was the speed of the fast car that is now equal the speed of the slow car will overlap. So then to do that, we would get the speed of the fast car equal the speed of a slow car plus 1 additional speed. That would give us the speed of the fast car. So if a slow car go x time around in 4 minutes, then the speed of the fast car would be a fast car, which is an x, and then plus 1, meaning the fast car go 1 extra lap faster than the slower car. And that number would help us figure out how much faster the fast car is going. And how we will find what x is, we need to have x equal to the slow of the speed of the slow car multiplied with the 4 minute, because it's x time around in 4 minutes, in 4-minute laps. And if we're looking for the speed of the sound, which is travel 1 extra lap, it would be x plus 1, and we will find the speed of the fast car times 4 minutes for that. So to find the difference between these two, we can just name that as equation 1, this equation 2. So then you take equation 2 minus equation 1, and when we look at this side, it's x plus 1 with an x, and then we take that, subtract from that, that will leave us with a 1. And looking for this other side, is multiply by 4 minutes, so you take the 4 minutes and then you multiply by the speed of the slow car minus the speed of, you take the speed of the fast car minus the speed of the slow car. So then you would take the speed of the fast car minus the speed of the slow car, and it's to go 1 mile, that's how far it's go around, so that 1 mile will be divided by 4 minutes, which will give us 0.25 miles per minute. And we can multiply 0.25 by 60, which is mile per minute, so then that would give us 15 mile per hour. So simply by knowing how many mile per hour they are moving far from each other, then we kind of figure this out. So if the speed of the slow car is running 100 mile per hour, then the speed of the fast car will be running 115 mile per hour. So then the fast car will be 15 mile per hour more than the slower car. And now we need to know how the car is related to sound. So this chart that you have made for a car and the sounds. And so when in car, when we are talking about speeds and sounds, the speed will be the frequency. And then in car, when we're talking about the difference of the speed, and sound will be the frequency difference. And in car, when we talk about lap time, and sound, it's either the beat or the pulse of spacing. So in car, when we are looking for the change in speed, we're talking about the track, so that would be the track over the lap time. But in sound, when we're talking about speed, that would be frequency, so the changing in frequency will equal 1 over the beat time. If you hear beating at 4 time repeats, you know that whatever it is, frequency of F2 equal frequency of 1 will have plus or minus the 4 Hz. And why do you have the plus and minus? It's because you don't know which one is going faster or which one is going slower. So you can either have a faster one or a slower, but it's different from each other by 4 Hz. And for example, for tuning a guitar, so then I have a control of F1, and then I want to make this 4 times back to 0, so then it's have the same frequency. So when it's have the same frequency, then the string is in tune. So then I will have to tune it down to get into the 0 frequency to make that the frequency of F2 and F1 have the same frequency. And this is just like the car example. When the car are going on the same speed, they will not overlap, and when they are having different speed, then they overlap. So having the same speed will not overlap, and they will not hear the wagga wagga. And for the frequency, when they are the same, then you will only hear one distinct tone. So for this last example that you have for us, we have frequency of 1, we know that it's 400 Hz, and frequency of 2 is 407 Hz, and you know that when you play them together, it's pulsing at 7 Hz, and you can see the difference there. It can be a negative 7 Hz too. And for frequency 1 here, equal 400 Hz, and then you have a pulse at 2 Hz, and then we have to figure out the frequency of the F2, but then you really don't know which one will be higher or lower. So then you can go two-way, which is you can have 400 plus 2 or 400 minus 2, and it will give you that.